Hi, 8th grade students. So this video is actually the start of Module 2, where we will be spending a lot of time with proportional relationships. One of the things that we need to discuss, and we're going to do it for the warm-up here, is how to determine equivalent ratios. And as a 7th grader, you saw things like this that looked like this, and you called it a proportion. So we're going to talk about proportions and how to solve proportions. There is a really interesting thing about proportions. Proportion is basically just two fractions or two ratios that are equivalent to each other. So 1/2 equals 3/6. We can all agree those two fractions are equivalent. The unique thing that happens here is that if you were to multiply diagonally, 1 times 6 and 2 times 3, you find that those cross products, the multiplication diagonally, they're called cross products, are equivalent. So a really important property of proportions is that cross products are equal. I want you just to jot that down real quick. Cross products are equal. We're going to use this property, this fact, to help us solve these four proportions. So I'm going to do maybe number 1 for you, and then what I'd like you to do is pause the video and try to do 2, 3, and 4 on your own, and then come back and check answers. So number 1, we're going to do these cross products. We're going to multiply diagonally. So I'm going to do the easy one first. 16 times x, that is just 16x. And then when I multiply 7 times 48, I get 336. So I've already done that multiplication, but you could go off to the side and do it. And now we're going to use the fact that these cross products are equal to create an equation. And now we build off of what we learned in 7th grade about solving equations. Solving an equation means getting this x by itself in order to determine the value of x. So x is being multiplied by 16. In order to undo that, we do the inverse of multiplication, which is division by 16. And whatever we do to one side of the equation, we have to do to the other. So 16x divided by 16, the 16s just cancel and equal 1. So this is just x equals, and then when I do the division, 336 divided by 16, I get 21. So in this proportion, x equals 21. That makes these two ratios equivalent to each other. So at this point, try pausing the video and doing number 2, number 3, and number 4 on your own using this process. Welcome back. Let's just quickly check answers here in the warm-up. So when you do cross products here, you should get 9 times t, which is 9t. 90 times 5 is 450. So here's my equation once I do cross products, and then I would divide both sides by 9 to solve for t, and I would get t equals 50 in number 2. Let's check number 3. So since we have a whole number here, we could change it to a fraction, and now it just looks like a proportion. And I can do my cross products. P times 1 is just P, and then 10 times 1 is 10, so we don't have to solve anything here. P just equals 10. P's already by itself. It's isolated, didn't have to do anything. Change 250 to 250 over 1, and do your cross products. So 250 times Q is 250Q. 1 times 1,000 is 1,000. Divide both sides by 250, and you get Q equals 4. So make sure you got those correct. That's going to be really, really important that you know how to solve a proportion and determine equivalent ratios moving forward in this lesson. So if you had questions about that, be sure to ask me at some point during this week or in the coming weeks. So now we're going to move on and start our lesson. Here's the goals of the lesson. We're going to represent proportional relationships in different ways. We're going to represent them with tables, with lines, and with linear equations. We're going to compare graphs of proportional relationships, and we're going to compare two different proportional relationships that are represented in multiple ways, meaning one might be represented with a table, one might be represented with an equation, another one might be represented with a graph of a line. So you've studied proportional relationships. We talked last year in 7th grade about this constant of proportionality. We also learned what a proportional relationship is. So we're going to look at an example, and we're going to use this example to carry it into activity 1.1. So this is the ratio of women to men. It says government agencies and civil rights groups monitor enrollment data at universities to ensure that different groups are fully represented. One study focused on the enrollment of women at a certain university. The study found that 3 out of every 5 students enrolled were women. Let's underline that. 3 out of every 5. Use the findings of the study to write each ratio. So number 1, this is on page M2-8 of your book. So please do this with me. M2-8 of your book. Number 1, the number of enrolled female students to the total number of students. Well, it told us that 3 out of every 5 students were women. So the number of enrolled female students would be 3. And to write it as a ratio, you can write it as a fraction. That's 3 compared to the total number. It says every 5 students, 3 out of every 5. So this ratio of female students to the total number of students would be 3 to 5, or 3 over 5 as a fraction. Number 2, the number of enrolled male students to the total number of students. Well, in our previous question, it was number of female. If 3 out of every 5 are female, then that would mean 2 out of every 5 are male. So 2 male students compared to 5 total. So 2/5. Number 3, the number of enrolled female students to the number of enrolled male students. This one, let's think about a little bit here. So the ratio is going to be female, number of female, to number of male. That's what it says. Well, we know that the number of female was 3 out of every 5. The number of male was 2 out of every 5. So the ratio of the number of female to male would be 3 to 2, or 3 over 2. Number 4, the number of enrolled male to the number of enrolled female. So they've kind of flip-flopped it here. Number of male compared to number of female. So number of male, remember, was 2 out of every 5. Female was 3 out of every 5. So this ratio of male to female would be 2 to 3, or 2/3. And we're going to stop right there in this video. We're going to pick this up in another video later on for activity 1.1.